Good morning. Today we'll discuss about the folds. We have divided the topic fold into two divisions, folds part 1 and part 2. In folds part 1, we will see what actually the fold is, fundamental definition and its morphology, and some basic aspects about the folds. In our part 2, we will see about the genetic and geometric classifications of the folds and their topographical expressions. Let us start. Folds are nothing but these are the bends or curved developed over the planar surface, mostly the sedimentary stratas, creating into permanent deformation. So it can be defined as it is a stack of originally planar surface. Okay, so originally there was a planar surface, such as sedimentary strata, that are bent and curved during the permanent deformation. So fold is nothing but the bent or curve developed over the planar surface or planar strata. Folds in the rocks vary in size. We can have the folds of microscopic level as well as mountain sized fold. So there is a high versatility in the sizes of the fold. You can get a very fine size of fold, okay, even at the microscopic level, as well as you can get the mountain sized fold means a mega fold. So folds are usually common or are usual in those areas where tectonism is very active. The area which is suffering from tectonic activity usually develops folds. In the surface or in the area where the tectonism is not active or tectonically quite stable region, folds are not much common in those areas. Or the areas which would have been tectonically active in past or in geological past, they may show some of the folds, but now they would be tectonically stable, but in their past they were tectonically unstable. So usually the folds are the results of the tectonic activity or tectonism. So let us see what is the process of formation of fold. So fundamentally, I have shown you the formation of two types of folds, anticline and syncline. The concept is same throughout the topic of fold. You can see that how the compressional stress is responsible for the formation of the fold. So when we have discussed the types of forces, strain and strain, in that lecture, we have discussed about the types of forces. And in that session, we also studied the compressional force or compressional stress. So what actually compressional stress do? Compressional stress compresses the object. Okay. Here in geology, we are discussing about strata. So compressional stress will compress the strata. So as usual, that the strata, when compressed, will try to adjust itself. So if the volume of the strata is going to decrease because of compression, then of course it will bulge out in some another direction. In that case, it will develop a bend or a curve because it occupied the extra area for its adjustment. So this occupance or this adjustment results into the formation of the fold. You can see that compressional stress are dominant in the tectonically active areas. We usually won't get any compressional forces in tectonically stable areas. Say, for example, our area, like Deccan Plateau or Indian Peninsula, we at recent time we don't have any tectonically active zones, and because of which we may not get such kind of folds at present. But in Himalayas, which are tectonically quite active, they are still under the tectonic deformation, because of which very frequent encounters of fold can be observed in the Himalayas. As you know that the Himalayas are the tectonic mountains. So folds are very common in the region of Himalayas. But where the region is tectonically quite stable, you will not get any kind of such fold in recent times. There could be the fold from the past times, but you'll never get the fold of in the recent times. So tectonic compressional stress is the is the major reason behind the formation of the folds. If your curve goes upward, okay, if it behaves like arch, that is called as anticline, or if it behaves like a basin, it called as syncline. We will see how they are further classified in our next session. It is just for your kind information. Let us see the morphology of the fold. So the morphology of fold is quite complex. You can see here that there are multiple nomenclatures or multiple aspects which we have to study in the morphology of the fold. So let us discuss step by step. See, the curve point or the curve is either called as crest or trap. So if the fold is upward in direction, then it is called as crest, and if it is downward in direction or it is downward fold, it is called as trough. The two sides of the fold which joins at the crest or the trough are called as limbs, limb limbs. So the limbs actually joins at the crest or the trough. The point of maximum curvature is called as hinge point. You can see over there the red point. The point of maximum curvature is called as hinge point. Means the point which shows the maximum curvature. Both crest and trough will have the hinge point. The the line which joins all the points of maximum curvature is called as hinge point, hinge line. Okay, and the zone is called as hinge zone. Okay, so the point of maximum curvature is called as hinge point, whereas the points, the line joining the highest curvature point will be called as hinge line. The plane which divides the fold into two equal halves is called as axial surface or axial plane. Okay, so this is the imaginary plane which divides the fold into two equal halves. Hence it is called as axial plane or axial surface. The intersection of axial surface or the axial plane with the fold is called as fold axis. So you must be very clear that the plane which bisects the or which divides the fold is called as axial plane, axial surface. But whereas the line of intersection of axial plane and the fold is termed as fold axis. And further, on the basis of this fold axis, they are further classified into multiple types. Okay, even the plunge, when we have studied the plunge, we have seen that how the fold actually shows the plunge because it measures the angle between the fold axis and the horizontal surface. So this was about the morphology of the fold. Okay, so we'll just revise it briefly. That fold is the curvature. Okay, either it will develop the crest or the trough. The zone where the curvature is there, it is either called as crest or trough. Crest means if the fold is tapering upward direction, then it is crest, and if it is tapering towards down, then it can be called as trough. The point of maximum curvature is called as hinge point. The line joining the all hinge points will be called as hinge line. The plane which divides the fold can be referred as axial plane or axial surface. The line of intersection of axial surface or axial plane with the fold is called as fold axis. And on the basis of this fold axis, we can classify the folds in multiple divisions, as well as we can measure the plunge of the fold with respect to the horizontal surface. So this was all about the basics of the morphology of the fold. Okay, so let us see some of the examples of the fold in the field. So you can see some of the well-known examples of the folds in the field. You can see how that the folds are developed in the field uh, depending upon the compressional force they have suffered and depending upon the rock strata under the compression. So it is very important to understand that The compressional stress is the deciding factor for the formation of fold, no doubt. But the strata which is subjected to the folding also controls the type of fold it will develop, because it ultimately depends upon the elasticity. Okay, what is the elasticity or what is the plasticity of that rock strata and etc. In our previous lectures, we have seen that there are some elastic limits and plastic limits for different rocks, isn't it? And we have seen the last plastic deformation, then we have seen brittle deformation. So fold comes under the plastic deformation. Okay, you can see in the field that how the strata has been folded plastically, and if you will remove the compressional stress, of course the stress has been removed from there, still they are not able to regain their original shapes. So such kind of deformation is termed as plastic deformation. Folds are very important in the perspective of the tectonical reconstruction, because fold explains much about the tectonic activities responsible for its formation. So tectonic reconstruction can be done with quite ease if you understand or if you learn about the folds. So this was all about the folds basics. It was the fold part one. Let us revise in short. Today it was the session on the fold part one, where we have seen the definition, morphology, and some of the significance of the fold. Then we have seen the definition of the fold. Okay, it is the stack of originally planar surface which underwent curving or bending due to the compressional stresses. It can vary from microscopic level to the megascopic level. Then we have seen its formation, that how the folds are formed. They are formed under the effect of compressional stress, okay, and they are most pronounced in the tectonic region where the compression stress are quite active. And the usually the folds are classified as the tectonic features, because in usual sense we won't get dominance over the fold, but sometimes due to depositional activity or other activities we may get fold. But the tectonic folds are quite common when you compare with the other types of folds. Then we have seen the morphology. In morphology, you have seen that how the different parts of fold are classified, are studied. We have seen that how limbs, hinge points, axial planes, fold axis explains the fold. Okay, the most important thing, the definition of anticline, syncline classification will be discussed in our next session. So this was all about the morphology of the fold. And then we have seen the field exposures of the folds and the significance from them, that how the folds are quite significant in the reconstruction of the tectonic history of that specific area. And the types of fold and the folding process also depends upon the types of rock which is subjected for the folding. And lastly, we have seen that the fold is nothing but the plastic deformation, okay? Because on removal of the compressional stress, the rocks cannot regain their original shape. So it is a kind of plastic deformation. So this was all about the fold part one. Thank you very much. Thank you very much for your patience listening.